Welcome, welcome. We've been working with linear equations in this chapter, and what we're going to be working on in this section 1.5 is using linear equations in order to solve problems, word problems basically, right? All right, and it says here in the goal that you're going to use verbal models and other strategies to solve problems using linear equations. All right, that's our goal here. And let's start that with this example. The problem says that a road trip from Casablanca to Agadir spans 462 kilometers. How fast would you need to drive to complete the trip in 4.5 hours? All right, so Casa to Agadir, 4 hours and 28 minutes, but we're going to call it 4.5 hours. Now, every problem that we're going to work on in this video is going to be able to be solved by the use of a linear equation. And what we need to be able to do, first of all, is try to relate the different quantities that are being described. And the way that we're going to start doing that is we're going to use a verbal model. And I want to show you how this works. Now, this problem happens to involve a distance, right? We're going 462 kilometers, and it's asking for a speed. It's asking how fast you would need to go, and it is working with time as well. And so anytime you're working with a distance and a rate and a time, you ought to know a formula that you can use in order to relate those quantities. Because you know that the distance is always equal to a rate times multiplied by a time. Okay, now this is an example of what I'm talking about when I'm referring to a verbal model. We wrote out in words the relationship between the quantities and the problem. And that's going to help us to see where to put any numbers that we're given and where we need to place any variables for the quantities that we're trying to find. All right, so we know that we have a distance of 462 kilometers. Now we can work in the units a little bit later on. Let's just go ahead and write the distance in. And we're trying to find the rate or the speed, and that's how fast you would need to drive. And so we'll just use an R for rate. And then we're given the time that it would take. And so we can go ahead and substitute 4.5 in place of the time there, right? And once you're able to do that, this particular equation is super easy to solve, but generally speaking, once you've got the equation, then you're able to find out the information that you're asked to figure out for a problem. So for here, I'm going to write this a little bit more like what you'd normally see it as. We would normally not write R times 4.5, but we'd say that's 4.5 R. And in order to find out the speed that we would go then, simply we're going to have to cancel out the coefficient here. We're going to divide both sides by 4.5. And that will tell us that the rate is approximately, it's not going to be exactly, 102.6 repeating actually. So it is exactly that. 102.6 repeating kilometers per hour. And so we can say that the rate is approximately 103 kilometers per hour if we're going to go ahead and round this to the nearest three significant figures, which is a common thing to do. Now, how did I know it was kilometers per hour? I knew it was kilometers per hour because my distance was given in kilometers and my time was given in hours, and so if I divided distance by time, I was going to get kilometers over hours. Also can be written as kilometers per hour like that. Ask me about the notation in class if that's not something that you're familiar with. All right, let's try another example. How about this? You are setting up 6 cones in a line 5 meters long for a soccer drill. All right, the diameter of each cone is 30 centimeters, and there should be an equal space between each cone, as well as between the ends of the line and the cones. How much should there be between cones? And that's implied how much space should there be between between the cones. All right, now you can imagine what this looks like. In fact, I've given you a picture kind of to show you what it might look like with 5 cones instead of 6 cones. It would be very tough to set up a verbal model that we could use to figure out how much space is going to go between each pair of cones and between the end cone and the end line. But it wouldn't be so difficult to draw a diagram here, and a strategy that you want to use whenever possible when you're solving problems is to include diagrams, pictures, that kind of thing. We're going to use a diagram here, and watch how I make the diagram. All right, we know that there's supposed to be a 5 meter long line, essentially, and so what I've gone ahead and done is drawn a line and labeled the 2 endpoints here, And then the next thing I need to do is label the cones. Now the cones are going to be equally spaced, where there's space between the end line and the cone, and the same amount of space to the next cone and the next cone, and so forth. So what we want to do is go and place those 6 cones. We'll just use dots to represent them on this line. Or rather, I decided to use circles because we do need to show that the diameter of the cones is 30 centimeters. Now, I'm going to do some labeling of the distances here. Don't worry if your drawing's not perfect. All you have to do is be able to label the correct information on it. And the correct information on it is going to be the distance between each of the endpoints. Which, thinking ahead, I took the liberty of making that 500 centimeters because it was given in meters at distance, but the cone's diameters are given in centimeters, and so it made sense to convert all the units to the same thing. So make that centimeters, and then we'll label the distances between the cones each. That's what we're trying to find. So we'll label those as x, and then we'll label the distance between the edges of each cone, the diameter of the cone. All right, now that diagram I think makes sense to you. Now what we need to be able to do is turn what we see on that diagram into an equation. And an equation is a total distance equation. We would say that the total distance between the 2 endpoints is going to be equal to the total diameters of the cones plus the total distance between the cones. All right? And so let's try to make an equation with that. We know that the total distance is 500 centimeters. Then, you know what, I'll tell you what, I'm going to make a verbal model here anyway based on that picture. Total distance, we'll say, is going to be equal to the cone distance plus the distance between the cones, or the space distance I'm going to call it. All right, and here's how we're going to come up with that. We know that this is 500, the total distance. The cones, there are 6 of them, and they're each 30 centimeters in diameter. So that'll be the cone distance. And the spacing distance, well, there are 1, 2, 3, 4, 5, 6, 7 spaces in total. And we don't know how far apart they're spread, so let's just go ahead and put D for distance right there. Okay. Now all there is to do is to solve the equation. So let's go ahead and make this 180, and I'm going to see if we can do this mentally. We know that 6 times 30 is 180, and we know that we need to cancel out that 180 from the side of the equation with the variable. So let's subtract 180 from both sides, and 500 minus 180 is going to give you 320. All right, so that's equal to 7D. Then we'll divide by 7, and we're going to approximate this as well. It's not going to come out exactly. To 3 significant figures, it's about 45.7 centimeters that we're going to leave between each cone. All right, I guess on the field you'd probably actually eyeball it, but if you're trying to make it exact, this is the distance that you would need. All right, thanks. One more example here. All right, this will probably be the toughest of the examples that we'll work with. Let's go ahead and read through it. It says a teacher spends 20 euros on 16 packs of pens and pencils. Okay? Now, each pack of pencils is costing 80 euro cents, and each pack of pens is costing 2 euros. And it wants to know how many packs of each did the teacher purchase, if the teacher did spend a total of 20 euros on the 16 packs that they bought. Okay, so verbal model time, that's what we're going to start with here as well. Think about the quantities that are being related here. We're talking about a total cost, and we're talking about a cost for every pack of pencils. We're talking about the cost of every pack of pens. So how do you calculate the total cost? Well, it's by adding the cost of the pencils with the cost of the pens, isn't it? So here's the verbal model. So the total cost equals the pencil cost plus the pen cost. And I'm going to break that down a little bit further because we actually have to, within our equation, figure out how do you calculate the cost of the pencils and how do you calculate the cost of the pens. And hopefully this is kind of common sense. But here's how that would be done. You would have to multiply the number of pencils times the pencil cost plus the number of pens times how much each one of them costs. Make sense? All right, let's go ahead and work that out then. All right, we know the total cost is 20 euro. That's already taken care of. All right. Now, as far as the pencil cost, we don't know how many pencils there were, but we know that each cost 80 cents. And so what we can do is say that we have 80 cents times the number of pencils, and we can just say that N represents the number of pencils. Okay, now this next part is going to be why I called this a trickier problem than the rest. We know that we're going to add the cost of the pens to that, and we know that each pack of pens costs €2. And we also don't know how many pens we have. Now, I don't want to use an N to represent the number of pencils and an N to represent the number of pens if they're not the same thing. So there's one more relationship here that we have to pay attention to here. Remember that there are 16 packs of pencils and pens that were purchased. And we're saying that the number of pencil packs purchased is N. So how could we express the number of pens without using a different variable other than N? Well, the way to figure out how many packs of pens you purchase is to subtract the number of packs of pencils from the total number of packs, right? You would do 16 minus the number of pencil packs. Or in other words, we could say that 16 minus N is how many packs of pens were purchased. And that's the expression that we're going to plug in right here to do the cost. I'm kind of switching the order around right here. We're doing the cost, €2, times 16 minus N. Now we've got the difficult part out of the way. We've made an equation to relate the cost of the pencils and the pens to the total cost. Now all we've got to do is go ahead and follow through with the algebra, and we will follow our process where we're going to simplify both sides of the equation. The left side is already simplified, so we got 20. On the right side, we need to go ahead and use the distributive property first. So that will give us, let's see, 2 times 16, 32. And then 2 times negative N. We'll get minus 2N. All right, and then we've got some like terms to combine still. The right side of the equation is not yet simplified, so I'm not going to start moving things across the equal sign yet. 0.80N minus 2N would be negative 1.20N. Now, if it helps to do that subtraction when I was combining those terms, you could always write instead of 2, you could have written that as 2.00N, and I think you could recognize that 80 minus 200 would be negative 120. So you see where I got the negative 1.20N, even if you weren't using a calculator. All right, which maybe you were. Now what we're going to do is we're going to go ahead and divide negative 1.2. Well, you know what? I forgot a term. That's why this is looking funny. I left off the 32. So let's add the 32 here. And then we got to subtract 32 from both sides to isolate our variable term. That'll give us negative 12 equals negative 1.2. I'm just going to leave it at that. N. And I think you can tell that negative 1.2 will go into negative 12 10 times. And that tells us that we bought 10 packs of pencils. Now, if N is equal to 10, then 16 minus N is going to be equal to 6, correct? So the answer here, how many packs of each did the teacher purchase? The teacher purchased 10 packs of pencils and 6 packs of pens. All right, so you've seen an example of some different problem-solving strategies that you can use to solve word problems, and all of them included a verbal model. If you can make equations with verbal models, or if you can make diagrams to help you out, so many times the problem just becomes infinitely easier for you to handle. All right, thanks for your attention. Good luck with all of this. I'll see you next time.